Hi, we are from Ivanoel. We are here to prove you our company-based Capstone that takes a sustainable topic about power smart, cutting energy waste, boosting efficiency. Next. Meet our team. Darren as the machine learning team, Reyhan and me as the cloud computing team, Fina and Haris as the mobile development team. Next. As you can see, excessive electricity consumption is a critical challenge in Indonesia, particularly due to the country's hot and humid climate, which drives a high reliance on HVAC system for cooling. HVAC system, including air conditioning, space cooling, and water heating, account for approximately 60% of the total energy consumption in buildings. With increasing urbanization and rising temperatures due to climate change, the demand for cooling is projected to grow significantly. This intensive the environmental and economic repercussion of energy inefficiency, highlighting the urgent need for innovative solutions to enhance energy efficiency while maintaining system performance and indoor comfort. Next.
The increasing demand for energy-efficient solutions is motivated by rising by operational costs, environmental concern, and resource sustainability. Leveraging advanced technologies such as IoT and AI offers a promising path to address these issues. By enabling real-time monitoring and anomaly detection, data-driven application can empower building managers to make informed decisions, reduce energy usage, and align with sustainable energy goals. Next. Ivanoel provides API for accessing energy consumption data for real-time data and data history. Monitoring location included at AHU second floor, vital office chiller, vital office lift, and OPMC lift. Next. Data files for historical data is ID, position, active energy import, and reading time. Data files anomaly data is ID, position, active energy import, reactive energy import, apparent energy import, reading time, and anomaly type. Next.
So here's some of the tools that are used in our projects. There is Kotlin, Android Studio, and Figma for mobile apps development, JavaScript, Postman, Google Cloud Platform for cloud computing, TensorFlow, Scikit-learn, and Flash for machine learning. Next.
To address the problem, we explore three machine learning models: autoencoder, time series forecasting with LSTM, and isolation forest. First, the autoencoder was ruled out due to the lack of sufficient data to train a reliable deep learning model. Next, the time series forecasting was considered. However, missing data was disrupted the sequential nature required by LSTM, and the cost of running this model on Google Cloud Platform could ramp up our credit usage. Finally, I decided on the isolation forest model. It's simple and effective in identifying anomalies without heavy computational resources, made it the most suitable model for this project. Next. So here are some of the results from the time series forecasting model. Although it provides decent predictions here and there, the disruption caused by the missing data reduces its reliability. Additionally, the resource consumption on GCP wasn't aligned with our cost optimization strategy, which is why we didn't proceed with this approach. Next. Lastly, we see the results of the isolation forest model. This approach was chosen for its efficiency and ability to handle missing data effectively. And the red dots you see on the plot highlight the detected anomalies in energy usage, providing a clear and interpretable output. Overall, the isolation forest proved to be the best solution for our anomaly detection needs. Next.
So this is mockup from our applications. Next. Feature from our application is real-time monitoring that tracks energy consumption, providing information to identify usage pattern, visualization dashboard for displays energy consumption data in an intuitive and interactive interface. notifications alert to send real-time alerts to user when anomalous patterns are detected, and anomaly detection to utilize machine learning to identify irregularities in energy usage. Next.
I will explain the mobile architecture of our project. We are using the MVVM architecture, which consists of three main components: view, view model, and model. The view includes activities or fragments that directly interact with the user. This layer utilizes composable function and Android views to build the user interface. It communicates with the view model to manage stats and handle side effects. The view model acts as the bridge between the view and the model, calling function from the data sources to process or fetch the required data. This architecture ensures a clear separation of concern, making the application more modular, maintainable, and scalable. Next.
Here's the picture of our architecture. This architecture integrates IoT sensors, backend services, machine learning, and user interaction to enable efficient data processing and anomaly detection. Next.
Our deployment plan begins with the cloud architecture design. Next, we take into the step of represent it in graphical ERT design. Then we prepare the backend and API. After that, we integrate with the machine learning model and mobile app to take a test on it. And finally, we able to deploy into our app. Next.
Here is some of the API shown in the picture for detecting anomaly for each location. Next.
Our resource and costs for the cloud infrastructure are getting credits from $100 credits from Bangkit and $300 personal credits. Our services are using artifact registry, cloud scale, cloud run, networking, and compute engine, and any other services. Next.
The amount of time contributed by me hovers around 100 hours, and looking ahead, there are a few key next steps in developing our app. First, we plan to explore more research papers and investigate alternative approach. Second, we plan to use external features like weather and temperature, which could help us better understand the association with energy usage. Lastly, we can consult with experts in the field to refine our model further and enhance its reliability. Next.
Each of us, me and Ivanoel, contribute about 100 hours for these projects. There is some of improvement that could be made, such as explore scalable deployment strategies on the cloud platform, implement a more efficient resource allocation cost for the engine and SQL, enhance the security parameters such as protocols and the data. Next.
For the mobile development team, both Fina and I dedicated 100 hours each to this project. Moving forward, there are several areas for improvement. First, notification customization, allowing users to set energy threshold or specific types of anomalies for personalized alerts. Second, offline data viewing, that integrating with a local database to provide access to data even without an internet connection. Third, improvement of user interface design to be more responsive and intuitive. This improvement will help optimize the app's functionality and usability. Next, here is the video demo of PowerSmart. This video showcases the key features and functionalities of the app in action. Okay, thank you for your time and attention. We believe that IoT collaboration can drive us closer to the Industry 4.0 revolution through the integration of software, hardware, and engineering. Once again, thank you.